This is my Lab 3 report on the magnetic field bar of a bar magnet. In terms of the purpose of this lab, it was to evaluate the distance dependence of a bar magnet by exploring the magnetic field at observation points on axis and off axis, and then evaluating it with the Biot-Savart law. We could then compare results to our computational model to see any discrepancies. In terms of the results, the mu we calculated was 1.985. The measured off-axis magnetic field was 4.43 times 10 to the negative fifth, and the computational model produced an off-axis magnetic field of 1.87 times 10 to the negative fifth. In terms of the principles we plugged all of our data into our spreadsheet, which then plotted the data according to this plotted equation right here, which then would give us our n and ln k, since they were the slope and y-intercept. Then by plugging these values into our equations for the distance dependence of a bar magnet, as well as our derivation of the Biot-Savart law, we could then obtain our magnetic dipole moment to use our computational model with some calculations, which I'll show in the next few slides. Within the computational model, though, we used the general equation for the dipole at any observation location to calculate the off-axis magnetic field to then compare with our observed off-axis magnetic field. So in terms of the spreadsheet, as I mentioned before, we have our average magnetic fields for on-axis and the average distance, as well as our average distance and magnetic field for off-axis that we calculated. And then this is the plot we created, where this is n and this is our ln of k. So like I said before, our n we calculated for the plot was negative 3.19, and our ln of k was negative 14.74. By plugging these back into our other equations, we could then find mu, or our magnetic dipole moment, to which we could plug into our computational model. In terms of the experiment, the system was a magnetometer since it was experiencing the magnetic field. The surroundings was the bar magnet since it was producing it. And while the Earth's magnetic field was considered, it was canceled out, so technically it's not in the surroundings. In terms of initial conditions, I didn't think there were any since there's not an initial and final state within the experiment. And then this was just a procedure we went over where we aligned it with the Earth's magnetic field, so the x-component was 0. Then we detected the magnetometer within our phone, and we found the on-axis magnetic fields by finding the distance at which the x-component was 20, 70, 120, 170, and 220. These were 3 measurements per. And then we found the off-axis magnetic field by finding the distance at which the net magnetic field was 100 Tesla, then recording the y component of Earth's magnetic field and moving the magnometer this distance, and then observing the magnetic field at this location to find our off-axis magnetic field. This was also done 3 times total so that we could get an average, as I stated before with the spreadsheet. In terms of our coding, we plugged in our mu here, and then we obviously rearranged this equation to include our general equation for magnetic dipole at any observation location. We then implemented our observation points on axis and off axis, and we implemented those into arrows here so that we could see it within the GlowScript model. And then this was for our off-axis one, where it was the 45 degrees, and we could see how this one was compared to our actual experimental model. In terms of observations, the bar magnet did have near 0 in the x direction, since it was far away from the bar magnet and the Earth's magnetic field was canceled out. And the only other one that went with this was that it moved closer to the magnet, the x component increased instead of decreased. In terms of the results, we were comparing the off-axis measurement with our computational off-axis, which, as I stated before, were vastly different at 4.43 times 10 to the negative fifth and 1.87 times 10 to the negative fifth. Sadly, these were very different, and this could be a multitude of things, such as other electrical devices not aligning correctly, bumping the magnometer, or any steel or iron objects near the meter. While I tried to stay as accurate as possible, there's definitely 1 or more of these within the experiment that skewed my results. In terms of discussion, if the magnometer was not correctly aligned, then it would skew our results, as the Earth's magnetic field would be considered along with the magnetic field of the bar magnet and give us inaccurate results. And if you put 2 magnets end to end and ran the same experiment, the direction would stay the same, however the magnitude would be doubled.